Alright, here's a video for a couple problems in 4.1 through 4.3 review part 2. Okay, mainly going over stuff from 4.1 since it's been a while. Alright, so here in number 1, I kind of started it here for you. We know that x minus 3 and x plus 2 have invisible exponents of 1. And so since this is in factored form, for the degree, you're going to add the exponents just for the x's, all right? I know in the past what I've seen is some people will say the negative 2 has an exponent of 1, and while that's correct, we do not include it as part of the degree because we only include the variable, all right? So all that to say, the degree is 4. I don't care that it's 4, I care that it's even. And then the leading coefficient is negative 2. I don't care that it's 2, I care that it's negative, okay? So if you look back in your notes, remember we made like a little table or a chart, right? If you have an even degree, and if your leading coefficient is negative, your end behavior, right, is going to be down, down, okay? Then what I'm going to do is I'm going to solve for each of these factors, right? This is going to be x equals 3, right? X equals 1 and x equals negative 2. And remember, these represent your x-intercepts, all right? I'm also going to think about, okay, looking at each of these exponents at these factors, I need to remember what is the behavior at those x-intercepts, right? So at x equals 3 and at x equals negative 2, because they have an exponent of 1, the graph or the curve will just go, it just crosses straight through the x-axis, all right? So I'm going to say crosses through, all right? Same thing at x equals negative 2. For the middle one, right, at 1, because it has an even exponent, right, it's going to touch or just bounce, right? It'll touch that x-intercept and it'll bounce right back, okay? So here are my x-intercepts that I've plotted right here, right, my 3 points, okay? And what's also going to be helpful is if you have a y-intercept, okay? And so we can figure out the y-intercept by plugging in 0 for x and then working all of that out, okay? So when you plug in 0 and then you use the exponents and multiply by negative 2, you should get 12, all right? So at 0 comma 12, like way up here, right? I'm just gonna say this is 0, 12. All right. Okay. Now I know my end behavior is down, down. So at my leftmost x-intercept, which is negative 2, right? I'm going to just do a down arrow, and at my rightmost x-intercept here at 3, I'm going to do the same, right? It's going to be in a downward direction. Okay. Now at negative 2, right, and please be careful to, or make sure that you're looking at the correct factor, all right? So one mistake that I see, every year is this is the leftmost x-intercept, so they just automatically look at the leftmost exponent. No, right? This is negative 2, so make sure you look at the factor of x plus 2, okay? This has an exponent of 1, so we know that it's going to go just straight through it, right? Not as a line, but I'm going to do my best to draw this, so I apologize in advance, all right? So it's going to go up, okay? Now I also know that eventually it has to come back down to this 1, right? Because it has to hit this x-intercept. But I also know that there is a y-intercept at 12, right? So knowing that fact, okay, I know that it has to go up and hit 12 somewhere, right? And so I'm going to draw it so that it's going to hit the 12 on the way back down, okay? All right, so it's going to come back down. I'm going to do it dotted first to try and make it a little bit more accurate. Okay, now as I'm approaching 1, right? Now I'm going to look at my factor of x minus 1, and it's an even exponent. So I know that it's going to touch the 1, and then it's going to go back up. All right? And now there's this other x-intercept at 3, so I know that eventually it has to come back down, right? Now, you can make this as high as you want, okay? If you want to check your calculator, that's fine. And so, you know, I'm going to make sure that I draw this coming back down. Okay? And so there it is. Right there. Okay? All right. So that's number 1. Okay? Okay, here for number 2. I already started filling out some information here for you. The degree is going to be 3, right? Because there's this invisible 1, I'm going to add it to the 2. I don't care that it's 3, I care that it's odd. The leading coefficient is a positive 2. Again, I care that it's positive. And so according to my table, if I have an odd degree and a positive leading coefficient, my end behavior is going to be down up. Okay. Then I'm going to solve for my x-intercepts. This is going to be -1. This is going to be 3. And my behavior at those x-intercepts, right? At -1, since my exponent is 1, it's going to just cross through, all right? And then at 3, since it's even, it's going to touch or bounce. Okay. So I'm going to first draw in or plot my x-intercepts. Okay, so at -1 and 3. And then since my end behavior is down up, at my leftmost x-intercept, which is -1, I'm going to draw a down arrow here, all right? And then at 3, my rightmost x-intercept, I'm going to draw upward, right? It's going up, okay? I think it might be helpful to have a y-intercept as another point for guidance, right? And again, that means that x is 0. So when I plug in 0, right, that's going to be 2 times 1 to the first, and that's going to end up being -3 squared, right? And so you get y is equal to 18, right? So way up here, we'll make that 18. Okay. All right, and I think we might have enough, okay? So I know that at -1, since it's an exponent of 1, it's just going to go straight through it, right? So it's just going to go like this, okay? Now, I'm not sure if it keeps going up and then if it hits the y-intercept on the way back down, or maybe if it peaks at the 18 and comes back down. You know, regardless, right? As long as it's in this general form, I'm okay with it. And then at 3, right? And here's why it makes sense that it bounces, because it has to come back down, and then the end behavior was on the right side going back up, right? And so that's why it makes sense that it's going to touch the 3 and then come back up, right? So there it is. Okay. Okay, so going backwards, right? When you're given the graph and you're drawing or you're writing the polynomial equation, all right? So I started by labeling some x-intercepts here, and I know the y-intercept is at 0, 3, okay? So for -4, I know that that comes from x plus 4. At -2, that comes from x plus 2. And at 3, that comes from x minus 3, all right? And so I'm going to start by writing, okay, f of x is equal to x plus 4, x plus 2, and x minus 3, okay? And at x plus 4 and x plus 2, if you notice the graph, it just crosses nicely straight through, right? And so we know those are going to be invisible ones. All right. And then at 3, since it touches and bounces back up, we know that it has to be an even exponent. And so I'm going to write 2 here. All right. Now you should be asking though, what if it's 4 or 6 or 8, right? Any even exponent. And the way we check it, right, and I'm going to put a little arrow here, right, is turning points, right? And so turning points are these peaks and valleys, or the low and high points, right? So when it decreases here, right here, here's one turning point because it's going from decreasing to increasing, right? At the y-intercept, there's another turning point. And over here, there's another turning point. And so there are 3 of those, right? And so we said, though, the number of turning points, right, is always the degree minus 1, okay? So if there are 3 turning points, that means the degree must be 4, all right? Meaning these exponents have to add up to 4, okay? So because this was 1 and 1, that must mean that x minus 3 is going to be squared and not higher than that, okay? Now, we always need a leading coefficient, all right? You need to have this a value, all right? And so that's why we use the y-intercept, 0, 3, right? If x is 0, that means y is 3. And so I'm going to change f of x to 3 because that also represents y, right? I'm going to have a, and then I'm going to plug in 0 for x. Okay? So when I work out the right-hand side, right, that's going to be 4 times 2, and that's going to be 9, right? Positive 9, because negative 3 squared. And so here you end up with 72a, all right? And when you divide 72, this simplifies to 1 over 24 equals a. So my final function is f of x is equal to 1/24 x plus 4, x plus 2, and x minus 3 squared. All right. All right, so for number 4, this is the last one I'm going to go over. I started it for you here, all of the x-intercepts and the factors, okay? The y-intercept. There are 2 turning points, right? Here, the peak, and then the valley. So that means that the degree must be 3, right? Okay. And if you notice that's going to make sense because at each of these x-intercepts, it just goes straight through it, right? So those all get 1s, okay? And so when you add those up, it equals the degree 3, all right? I've got a y-intercept at 0, negative 6. So that means when I plug in 0 for x, the y value is negative 6. And remember, we need to figure out the a value, all right? So I'm going to do negative 6 is equal to a, 0 plus 3, 0 plus 2, 0 minus 1, right? And the right-hand side, that multiplies out to negative 6, so negative 6a. So a is just 1, right? Now, since it's 1, I guess you don't really need to write it, okay? So that's just f of x, and then all of the above just rewritten, okay? And there it is, all right? It also makes sense that the degree is odd, and the leading coefficient a is positive, right? It was positive 1, and so that's why the end behavior is down up, okay? So another thing to consider, all right? Let me know if you have questions, all right?